Hello students, welcome back to my channel again. Today we are going to discuss about class 9's volume and surface area chapters. The topic right circular cone. So let's start with the video. Why it is called right circular cone? For that we need to know first that how we can generate a right circular cone. So for that reason, we will just draw a rough sketch of a right angled triangle. Okay? You think about this. These right angled triangles, perpendicular part is its rotating axis. Then suppose you are holding over here. Think about the situation that you are holding like this, the axis you are holding like this, and then you are just rotating it in this way. The axis you are rotating, that means you think about this pens, this part handle, this one you think like right triangle. Then when you will just rotating it, you will be getting one generating circle. Okay? And for this right circular cone, we need to have right triangle and we will rotate it and we will go from 0 to 360 degree rotation. And then we will get, look, this line, middle line will be fixed. This line will go this side, this side, this side, like this. So this point, this one will make a circle. Will make a circle. And the right triangle will make this type of figure. Yes or no? This one will come this side, this particular point coming this side, and this way, and this way, and then finally will come here. Starting and ending point will be same. For that reason, we will get the circular part in the bottom and we will get a pyramid like structure, and the base is circular, that's why it is called circular cone. And this generating triangle is actually a right triangle, that's why its name is right circular cone. Okay, again I'm repeating, you just need to have a right triangle and its perpendicular part will be its axis. Just you have to rotate through its axis and you will get a generated cone. For that reason, this is called right circular cone. Okay? Now I'm just drawing right circular cones, a very simple figure, so that you can understand its rest of the part. Okay? So this is right circular cone. In right circular cone, there are some notations that are generally used. So we need to know that circular basis radius will be noted with R. This oblique, that means you can say the hypotenuse of the right triangle will be called as L, that is slant height, slant height because it is not perpendicular, little bit oblique, slant, okay, inclined, that's why slant height. And this one perpendicular will be h, this is only height. So there are three notations in one right circular cone: h, height of the cone; l, slant height of the cone; and r, radius of the circular base. Now, depending on this particular figure, there are three formula related to right circular cone which will be used in your syllabus for doing several sums. So the first formula we will be getting as curved surface area of a cone. Curved surface area of a cone. Its formula is pi RL square units. Curved surface area of a cone is pi RL square units, okay, where L is slant height and R is radius of the base. Okay, now there is another topic, that is relation of R, H and L. Now you can see this right triangle. So as it is right triangle, we can apply Pythagoras law on it. And by Pythagoras law we can write L square equals to H square plus R square. That means we can say L equals to root over of H square plus R square. So this is the relation among R, H and L. Or if you want to find H, then H will be root over of L square minus R square. Or if you want to find R, then it will be L square minus H square. So the main thing is that there are three unknown numbers. If you know any two numbers values, third one can be found very easily. Any two you need to know, so third one can be found very easily. Okay, so curved surface area of a cone pi r L, and L's formula is root over of H square plus R square, where H is the height of the cone, R is the radius of the base and L is the slant height. Going to the next formula, that is total surface area of a cone. Now curved surface means this rounded part. Total surface means curved surface plus the base, this base. So total surface area of the cone is CSA, curved surface area, plus base area. Now CSA means pi RL and base area means pi r square, because this is a circular base, so base area pi r square. So total pi r square square units. That means we can take pi r as common from both and we can write L plus R square units. Okay, so this is TSA. Coming to next formula, that is volume of a cone. Volume of a cone is very interesting. Its formula is 1/3 pi r square h cubic units. Now 1/3 pi r square h, you can relate to this part pi r square h. Pi r square h is volume of cylinder, right? That means we can say that volume of a cone is 1/3 of volume of a cylinder. Okay, that means suppose you are taking one cylinder like this and one cone of same circular base and same height. This height is same for both and their radius is also same. Then to just make it full, this right circular cylinder, you need to have 3 times full of this cone. Okay, so you can do this activity at home also, and you can cross verify this result by your own. It's very simple activity yet very interesting, so you can do it by your own. Now we will start the exercise 13.3. But before starting the exercise, I would like to repeat the formula once. CSA of a cone equals to pi r L square units. L equals to root over of h square plus r square units. TSA equals to pi r into L plus r square units. And volume equals to 1/3 pi r square h cubic units. Okay, so these are the formula which will be used for doing 13.3 and 13.7. 13.3 is actually the formula related to surface areas, and 13.7 is the exercise related to volume formula. So let's start with some questions of exercise 13.3. So I'm doing question number 5 first. Question number 5 tells that I have written the question over here so that you can relate to the question and the answers at the same time. What length of tarpaulin 3 meter wide will be required to make conical tent of height 8 meter? Look, I have drawn the tent here, and base radius 6 meter. Assume that the extra length of material that will be required for stitching, margins and wastage in cutting is approximately 20 centimeter. So from this assuming part we will be looking into later. So first we need to find out what length of tarpaulin will be required to make the tent. So the tent will be obviously like this, and tent's lower part will never be covered with the canvas or with the cloth or with the tarpaulin, just this part, okay, surrounding part. That means we need to have its carved surface area. Okay, now base radius given as 6 meter, so it is r. 8 meter is the height, so this is 8. We need to find out L, that is slant height of the cone. Now we all know that slant height formula, L equals to slant height. Formula will be root over of h square plus r square. That means we are getting h square means for h 64 and r square means 36 meter. So it's coming root over of 100 meter. That means 10 meter. Okay, so we have got L equals to 10 meter. Therefore, we know curved surface area of a cone, that is pi r L square units. Pi we have to take 3.14 because it is given. Otherwise, you could have taken 22/7. but as it is given in the question, we have to take 3.14 as it is given in the question. So 3.14, R means 6, L means 10 meter square. That means we are getting 3.14 into 60 meter square. Now I'm not doing the calculation now because this is not the final one. Now CSA we have got, but the question is not to find directly the CSA, rather the length of the tarpaulin 3 meter wide. You are to find out length of the tarpaulin cloth. Okay, so you think about the tarpaulin like this. It is, suppose, obviously the pieces of clothes always you can see, you can go to any textile shop, any sari shop, you can see this means cut piece that is rolled, just surrounded one simple pipe or simple stick like this, but ultimately that is rectangular in shape and its width has been given as 3 meter. That means B, suppose we need to find out its length, but the area we have got, that is 3.14 into 60 meter square. This is the area. So the rectangle's area we have got the width, we need to find out length. So we all know that length into breadth equals to area of a rectangle. Okay, here area of the cloth or area of the tarpaulin. That means L into B means 3 here. Area is 3.14 into 60. So from this L will be 3.14 into 60 divided by 3. 360 20. So 3.14 into 20 will be 62.8 meter square. Now 62.8, sorry, not meter square, 62.8 meter, because it is length, not area. 62.8 meter we need it. For that you can write 62 meter 80 centimeter. Okay. Now look at the question. Coming to the second part of the question. Assume that the extra length is approximately 20 centimeter. That means we actually need this one, but we had to buy 20 centimeter more, because when we stitched it and cut it, some wastage for margins and cutting wastage were there. That means we need to add the wastage to this required part. So what will be here? Length of the tarpaulin equals to 62 meter 80 centimeter plus 20 centimeter, that is equals to 62 meter plus 100 centimeter. 100 centimeter means 1 meter, so ultimately it's 63 meter, and that's our answer. Now coming to exercise 13.7, question number 7, and this is the exercise related to volume of a right circular cone. So right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. Revolved about the side 12 cm, that means 12 cm side is the axis and it's rotating just through this axis like this. This is the generating figure. So obviously the solid will be a right circular cone. As we already got the information from very first of this beginning of the video, so we have got this generated right circular cone whose h equals to 12 cm, because this is the rotating axis. Pipes will be base radius and slant height is 13 centimeter. We need to find out its volume. It's very simple. Volume of a cone. First we will write that the solid so obtained is a right circular cone. This must be written with height 12 centimeter and base radius 5 centimeter. Must be written. Now we will write down volume of a cone equals to 1/3 pi r square h cubic units. That is equals to 1/3. Here nothing is given for pi's formula, pi's value. So we can take 22/7. R square means 5 into 5. H means 12. It's centimeter cube. So nothing is being cancelled. So it will be 22 into 25 into 12 divided by 21 centimeter cube. And you need to just calculate this to get the answer. So I am not calculating it because it will take much time. Okay, so this is the question for question number 7. It's very simple. But why I have chosen question number 7? Because it was not a direct question. You need to know that how a right circular cone is generated. Okay. Coming to question number 8. You look at question number 8 once. Question number 8 is not a new question. It is actually a part of question number 7. Here in question number 7, the axis was the side 12 centimeter. Now in question number 8, it is telling that the axis will be the side 5 centimeter. So what will be its figure? Its figure I am roughly sketching. Okay, the figure will be like this. I am very bad at drawing any figure. Okay, so this is just a very rough sketch. So now it will be R equals to 12 centimeter, H will be 5 centimeter and L as it is 13 centimeter. Why this type of figure? Because now in question number 8 it is told that you have to revolve the triangle about 5 centimeter side. That means 5 centimeter side is the axis. So that will be height, axis will be the height and base radius will be the other side, that is 12, and L will be obviously the hypotenuse. So we will write that the same thing, that the generated solid is a right circular cone. Okay, with H equals to what? 5 centimeter and base radius 12 centimeter. Okay, that means we need to have its volume now. Volume equals to 1/3 pi r square h cubic units. So 1/3 22/7 into r square means 12 into 12 into h means 5. Only 3 will be 3 and 12 can be cancelled with 4. 3 4s are 12 centimeter cube. So we can get finally 22/4 into 22 into 4 into 12 into 5 divided by 7 centimeter cube, you need to find out its answers. Okay, but here the question is not ended. The last part of the question number 8 is asking you that you need to find out question number 7's volume and question number 8's volume's ratio. And as I have to find out the ratio finally, that's why I will not take the answers part. Rather, I will be taking the second last line of the calculation. This one and this one. Look, this and this. These two we will take to find out the ratio. Okay? So, we will find out the ratio of, suppose, volume 1 and volume 2. Volume 1 is 22 into 25 into 12 divided by 21, and volume 2 is 22 into 4 into 12 into 5 divided by 7. Okay. So, I'm writing it properly so that everybody can understand, and I am sure that all of you are well known about fractional division. This denominator will come to the numerator. Okay. So it's like this, and ratio will not have any units. Look, 22 will be cancelled out. 5 5s are 25, 12 will be cancelled out, 7 3s are 21. So there is nothing else. In the numerator we have only 5, and in the denominator we have 3 and 4, that means 12. So the ratio is coming as 5:12, and this is the final answer. Okay. I hope you all have understood question number 7 and question number 8. These two questions are very, very important. Rather, these are very easy, but yet so important. And the previous questions also. Now, exercise 13.7 and exercise 13.3. These two exercises, rest of the questions will be your homework. Rest of the questions are very, very easy, and some of the questions are direct questions. So I know that you all can do it. Just you need to copy this, and you need to keep this copy while doing homework just with you. Okay? So this is all about today's session. We will be meeting in the next video with some other topic. Till then, bye-bye and thank you.